All right, 8.3 notes. We're continuing from the vocab that you learned in 8.1 and 8.2 notes. We're continuing with more definitions and relationships about circles. So the first thing is we have degrees in a circle, and the most important thing to remember is that you have 360 degrees in a circle, and that's going to help you find arc lengths. That's going to help you find inscribed angles or other things in the circle. So we have finding the missing arc length. So why is this helpful? We have 360 degrees total. We subtract what's given, which is 140. And then we're able to find the missing arc length, which is 220 degrees. And a missing arc, the missing arc is this side. All right, an intercepted arc is the arc that is formed when segments intersect points of a circle and create an arc. You really won't see the words intercepted arc, you'll just see arc. So this is an intercepted arc. It just means that there's lines between it instead of just having something like this. You know, it has an angle in there too. So that's an intercepted arc. We have the circle ABC. We have this intercepted arc in there, and the intercepted arc would be HC. And if you want to find the measurement, if they're asking for the measurement, that's when you see the M in front of it. And so the M stands for measurement. All right, we have a central angle, and the angle, that's an angle whose vertex is in the center of the circle. So it's just an angle that the corner, remember vertex means corner, is in the center. The central angle and the intercepted arc length are equal. So if this is 50 degrees, then this is 50 degrees. And, you know, if it's 100, then your central angle is also 100. And that helps you find that helps you find arcs and angles depending on what you're given. So on this side we have find the value of x, and so since this is a central angle, then we know that x equals 80 degrees. And for the second problem, it's asking us to find the measure of arc AC, and this is 30 degrees right here. So therefore, the measure of AC is also 30 degrees because it's a central angle. All right, then we have an inscribed angle, and notice the big difference between the last angle, central angle, and an inscribed angle is that an inscribed angle is the vertex is on the circle. So whereas the central angle, the vertex was in the center, this one is actually on the circle. It's an angle whose vertex lies on the circle. The measure of an inscribed angle is equal to half the measure of the intercepted arc. And actually cross this off. That shouldn't be BAC. That should be the measure of angle ABC is equal to half of the measure of AC. So if we use that for the examples, find the value of each variable below. We have some given arc lengths, and we have to find the degrees of x, y, and z. The first one that we can look at, well, first notice that these are inscribed angles, just like the definition said. So if I'm looking at z, then z goes from here, like the angle, that's the angle right there. And those are the segments, those are the chords that make up that angle. So our rule is we take half of the arc length. So half of 170 is going to give us z, and that's going to be 85 degrees. So Z is 85 degrees. And then we can use the arc length 90 to help us find X. So if you notice, X starts there and then it goes there. So that's the angle for X. And that's half of 90. So that's 45 degrees. So X is 45 degrees. And we still have Y. But remember that from the triangle sum theorem, 3 angles in a triangle add up to 180 degrees. So we can use that to figure out the third angle. We subtract 180 minus 85 minus 45, and we're going to get 50 degrees. So Y is 50 degrees. The degrees in a circle are 360, then you also know that this one is 100. And so if that's 100 degrees, then Y should be half of that, and that's why it's 50. So those are 2 different ways to solve for Y. Find the value of AC. So we have an inscribed angle right here, and we know that angle ABC is 90 degrees. So if that's 90 degrees, then the measure of arc AC is twice as much. If we go backwards from here, you multiply both sides by 2, and that'll be backwards. So we have 90 degrees times 2 is 180, and the measure of AC is 180. All right, if we look at tangent lines, so tangent line is a tangent intersects a circle exactly at one point. And we went over a tangent line in the last set of definitions, but what you didn't go over was that a tangent line, when you draw a radius across from the center to the tangent line, you get 90 degrees. So anytime you have a tangent line with a radius, you're going to get a 90-degree angle. It says if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of the tangent. So that one point where it intersects, if you draw a line to the center, which is your radius, you've got 90 degrees. So that's going to help us find missing sides or missing angles, because remember, we have SOHCAHTOA, which you can use anytime you have a right triangle. So that doesn't go away. You're still going to use that several different places when you have a right triangle. And if a line is perpendicular to a radius at its endpoint, then it is tangent to the circle. So that's just the second half of that definition. So we can use SOHCAHTOA to find different angles or sides. And let's see the problem and see if we have to use it. So is line M tangent to circle O? So we have to figure out if that's 90 degrees. And it is, because we didn't have to use SOHCAHTOA. Just keep that in mind for other problems. But we know that it's 90 degrees because that's by definition. So yes, line M is tangent to circle O, because it only intersects at one point. And that's why it's 90 degrees. So it's perpendicular. And then our last vocab for this lesson, we have two tangent theorem. So it's a theorem, it's not a definition, but it's going to help us. So we have the two tangent theorem tells us that two segments tangent to a circle drawn from a common exterior endpoint, and that's quadrilaterals have an angle sum of 360 degrees. So you want to make sure you remember this for when you have a quadrilateral in a circle, or when you'll see for the next example when you have a quadrilateral right there. See, you have 1, 2, 3, 4. That's a quadrilateral. It's a kite. So the two tangent theorem tells you that NP is congruent to OP because they're both coming from the same point. They're coming from point P, and each one is tangent to the circle. It touches only at one point. So therefore, when you make the radius connect to N and then another radius connect to O, you get a quadrilateral, just like in the next example. So it's telling us to find the value of X. So if you remember with your quadrilaterals, opposite angles are equal to 180. So that means, it should be obvious because this is 90 degrees and this is 90 degrees. So if you add those up, you get 180. But the other opposite angles are also supplementary. So 130 plus X equals 180. We subtract 130 from each side, and we get X equals 50 degrees. And that's why it reminded you that quadrilaterals have an angle sum of 360. But I will also add that in quadrilaterals, remember that opposite angles are supplementary, which means that they add to 180 degrees. In case you forget what supplementary is. And those are the definitions for this lesson. And make sure you still refer back to the definitions from the last lesson because they'll be consistently used throughout the chapter.